We're good. All right, hey everyone. So I'm Feross, and I'm here to talk to you about the peer-to-peer web. And when I say peer-to-peer web, I'm talking about WebRTC. So WebRTC is awesome. It's a way for two browsers to talk directly to each other, completely peer-to-peer. And so traditionally, the way a lot of web services are built is a model like this, where you have a central server and you have browsers talking to each other, but through the central server. So the server can see everything that the peers are doing. And this is like how Facebook chat works and how most of the web services that we use every day work. What we want to do with WebRTC, and what WebRTC enables us to do, is to build services like this. So it's better for privacy. It's better for just if you want to save bandwidth, it's architecturally a lot nicer, and it's actually going to allow us to start to decentralize the web again, which makes me really excited. So on hearing about this, you might have some questions like, how is this possible, right? I mean, what about security? Having browsers open up connections to each other sounds like it could be dangerous. What about the same origin policy? Does that even make sense anymore with something like this? What about asking the user for permission before you open up a connection like this? What about users behind firewalls or NATs? How is the connection going to work? And isn't this crazy? Isn't this just madness? And as it turns out, WebRTC actually has a solution to all of these problems and more. So peer-to-peer is actually possible in the browser, and it's not crazy. It's just WebRTC. It's the world of black magic. So let's talk a little bit more about it. So it's a web standard. It's a W3C and IETF standard, and it exposes a simple JavaScript API to you. It supports voice and video with amazing video quality. And this is the part that really excites me. It also supports arbitrary data, both reliable and unreliable. So you can build whatever kind of application your imagination allows you to build. And like I said, it's peer-to-peer. So why is this exciting? First of all, if you ask that question, you should probably just leave, because it's obviously exciting, right? It fundamentally changes the web, and it makes it more powerful. As the WebRTC lead at Google said, WebRTC is really just, it's a project to bring real-time communication to the open web platform. So really, it's about making the web more powerful, adding new features to it. So a few more things about it. There's no installation required, of course, because this is a web standard. It's built into the browser. So it currently works today in Chrome, Firefox, and Opera, which is about 50 to 60% of the market, depending on your particular website. And what about Microsoft, right? What about IE, and what about Safari? Turns out I'm pretty optimistic about those browsers and their plans to support WebRTC, because Microsoft has a new site now where they talk about their plans for supporting web platform features. And this is what they have up there for WebRTC. So they say, we don't like the current API, we're not currently planning to support that, but we want to support this other thing, which is the object API, which will let you do the same thing, but it'll just be a different API. So it's not ideal, but it will allow us to abstract those differences away, and we'll be able to have different browsers talking to each other. And what about Apple? So Apple's been very quiet, but there's this post on a mailing list, on the WebKit mailing list, where they're beginning to merge code from Blink, which is Google's fork of WebRTC, Google's fork of WebKit. And they're starting to merge some of those changes back into WebKit, which is really exciting. So I think they're planning to support it at some point. And yeah, so like I said, we have three browsers that support it today. If you have an Android phone, Chrome and Firefox on Android also support it. So it works across devices. And I want to show you guys some examples now of cool things people have already built with this today. So let's take a look, just so you can get an idea of what is possible. So let's get this over here. OK. So this is a really cool service. How many of you have heard of Talkie before? Oh, wow, that's way more than I expected. Cool. So anyway, this is a simple video chat service where you can really quickly get up and do a chat with anyone you want. So you type in a name for this conversation, and anyone who goes to this URL here will be in a video chat with me. So why doesn't someone just type that in really quick? Talkie.io/test. And let's see that it works. Nice. Hey there. Cool. So yeah, and you can chat, and it's no plugins required, no installation required, multi-party chat. It's pretty freaking cool. No account is necessary. So this is probably going to crash my computer. Anyway, I'm going to close this now. So there's other uses as well besides video and audio. So this is a really cool example. It's called ShareFest, and it's a way to send files from one computer to another really seamlessly. So all I do if I want to use it is I drag a file from my computer. Let's drag this file here, drop it on this page, and is the internet going to cooperate with me? Let's give it another shot. There we go. So cool. So it gives me this little URL here, sharefest.me/CA9813BB. If one of you guys wants to type that in, you'll be able to download the file that I just dropped on my browser. So again, no installation was necessary. You didn't need to install Dropbox. You just visit this URL, and then the server will coordinate that our computers will connect to each other, and then my computer will actually send the file directly to whoever visits this URL. And it's completely peer-to-peer. The server never sees the content of the file, and it's streaming, which means that I can start to send you the beginning of the file, and you start to receive the bits right away. And so it's, in my opinion, better than Dropbox because you don't have to wait for the entire file to upload to the server before people can start to download it. So it's really great for getting files quickly to people. And if you're on a NAT, if you're on a local network, then the file never leaves the network. So it's super fast. It will go over the local network. I want to go a little more quickly through these other examples. So this is PeerCDN. This is a company I started. And we used WebRTC to enable enable browser cache sharing. So the idea was if you visit a website and you download a bunch of resources, images, videos, and things, for the duration of the time that you're on that page, you should be seeding that content to future visitors. So it reduces the load on the server. And that was kind of a cool idea. We were able to reduce people's bandwidth. There's Together.js, which is a way to drop in video chat into your site. There's Chromecast is using WebRTC. They're using it for the tab casting feature. So when you want to send the content of your browser tab to your TV, that actually uses WebRTC. Amazon is using it in Mayday, which is a way to have one tap button on your Kindle and talk to a support agent. So you just tap a button, you wait like 5 seconds, and then you're on the phone, and you see a support agent on your Kindle, and you can talk to them and figure out whatever problem you're having. And lastly, Snapchat acquired a WebRTC company for their video feature. So WebRTC is everywhere. It's pretty cool. But there's this quote from Chris Cranky, who's kind of like a WebRTC analyst dude, really cool guy. And he said he popped into a recent HTML development conference, and he was surprised at a lack of general knowledge by the geeks at large about WebRTC. So these examples I've shown you are pretty cool, but there aren't many more besides these. So what I think WebRTC needs is like more recognition by web developers and more understanding so that we have more apps besides these. WebRTC has been out for 2 or 3 years in production browsers, and there aren't many more apps besides these ones that you've seen here. So I'm hoping that after my talk today, you'll feel more comfortable going out and building some WebRTC apps yourself. So what we need is more mad science. That's what web developers bring, is mad science. So I want to show a couple more things that I think are mad scientific. There's PeerServer, which is a server in a browser. You can basically, it's an IDE, you can build a whole site with a backend and stuff, and then you push host, and then you get a URL, and it's completely served from your browser, which is kind of neat. And then there's WebTorrent, which is my project to build a BitTorrent client in the browser, which I'll mention a little bit more about later. which I'll mention a little bit more about right now. So, WebTorrent is a BitTorrent client that requires no installation. So, like I said, no plugin, no extension. And the goal is to have it interoperate with the regular BitTorrent network. So, I want it to be the kind of thing where it's in the browser, it talks to existing clients, and it streams videos to you. And so it'll be really easy to share links, and it's all on the web. And this sounds crazy because you can't just open up random sockets, UDP and TCP, to talk to BitTorrent clients that are out there. So we're going to have to be a little clever about how we accomplish this. So just really roughly, this is how the plan is to make it work. There are BitTorrent clients out there, right? They talk to each other. That's represented by these orange links. They're speaking the BitTorrent protocol. And then we're going to build some hybrid clients. So these clients are going to speak the BitTorrent protocol, obviously. They're going to be able to talk to the existing network. But there's going to be these new types of clients, which are web-only. They only speak WebRTC. And they're going to speak to the hybrid clients. And but the hybrid clients will speak both, right? So if you're a web client and you want to download something, and you have like the info hash of the torrent, you can do it as long as another web client has it, or as long as a hybrid client has it. If a normal BitTorrent client has the file you want, and that's it, then you're unfortunately not going to be able to download it, because this is not possible. You can't. WebRTC can't. It's not the same as TCP UDP. It's a fundamentally different thing. So these middle nodes are really going to be really important. And so the plan is to build a native client. That's the hybrid one that was in the middle, and it will be a native client that you can install. And then later to build the web client. And then to add WebRTC, obviously the web client uses WebRTC, but to add WebRTC to the native client as well, so it can talk to the web ones. So I started on step 1. I wanted to build a torrent client. And I started writing all these modules to accomplish that. And I kind of got sidetracked and wrote a ton of them, and basically built a whole BitTorrent client in Node. And it was kind of cool. I figured I should understand how this works before I attempt to do it using WebRTC. All these modules are small. They're little pieces of functionality that you need to implement a client. And what's cool is they're actually used by some other projects. There's this really cool project I encourage you to check out. It's called PeerFlix. And it allows you to stream torrents to VLC. So you just type in the URL, the magnet URL, or the link to the torrent. And then you wait like 5 seconds, and then VLC opens and it starts to play. And it's really cool. And you can seek, and everything just works. And then there's even a crazier project, which is called Torrent Mount, by the same guy. And it actually allows you to mount an entire torrent as a file system on your computer. And when you open up any of the files, it will live fetch it from the network in order to show it to you. So it's crazy cool. The guy's GitHub page is github.com/Macintosh. It's totally worth checking out. But anyway, back to WebTorrent. So most of these modules that I showed you are going to be browserifiable. So they're going to be able to run in the browser, and that work will be able to be reused for WebTorrent, which is pretty cool. And the ultimate goal is to get to something approaching this, where you can just include it in a page as a script tag. And then you can call a function that says, I have this PDF, here's the hash of it. Please show it to me in this div called viewer, and then it will just fetch it from the network and show it to you. Similarly, for video, you could just do something like this. You could say, here's the movie. Once you get the stream, just put it as the source of the video, and we're good. So that's WebTorrent.io. But what I want to spend the rest of my talk talking to you about is, back to Chris Cranky's quote, I want you guys to leave feeling like you feel empowered about WebRTC and you can understand it and do stuff with it. So I thought it would be cool to try and build a clone of Omegle right now. So how many of you have heard of this site? It's like chat roulette. How many of you have heard of that? OK. Wow, more of you have heard of Talkie than have heard of chat roulette. That's surprising. Anyway, so it's basically a site where you go on and you can talk to random strangers. And it uses Flash. And I thought we could build the same thing but using WebRTC. So first thing is there's this API we have to use called getUserMedia. And it's really simple. All we do is, let's see, can we show my editor? Yep, cool. OK, so all we're going to do is we're going to call this API, getUserMedia. It's browser prefixed, unfortunately, so that's why I'm saying WebKit getUserMedia. And it has a success and a fail callback, and also some constraints. So for the constraints, we're just going to say, give us video. We're not interested in audio for this demo. And for the success callback, we're going to get the stream, and we're going to create a video tag. And then we take the stream and we turn it into a blob URL using this, this call right here. And then we set it as the source of the video and play the video, and then add the video tag to the DOM. And if we fail, we just print out the error. And so we can see that in action. It's just right here. So I'll refresh. So you see the browser is asking to use my camera. I'll click Allow. And and it works. Cool. Nice. So really easy, really simple. But the thing is, this only works in WebKit. So let's fix that. Let's make an abstraction layer to make this a little bit nicer to use and clean up some of the rough edges. So one thing we need to do is handle all the possible names of this API. So we do that with this big chained OR statement. And we're going to export a single function. So I'm writing this in Node style because I'm going to browserify it. So I'm going to export a function called getUserMedia, and then it's just going to call getUserMedia. And it'll pass in the constraints that the user passes in. And what we're going to do is we're actually going to transform the API to be Node style, with error first, callback style, just because I like that. So we're going to have a success and a fail function. If we're successful, we just call the callback with null first. And if we fail, we just call the callback with an error first. Really simple. And let's make this a little bit nicer. So let's allow the user to omit the constraints if they want. If they omit the constraints, we just set that to video true and audio true for them. And then lastly, there's one thing we need to do to fix this up in Firefox, which is Firefox, when it calls fail, sometimes error is, well, actually, always error is actually a string instead of an error object, which is a little bit annoying. So what we're going to do is we say if error equals this particular string, which is that the user denied us permission, then we're going to create an actual error object and emit that. And we do that with this module called custom error, which allows us to just create a new error object that inherits from error. And then we do that also for constraint not satisfied, which is another type of error that it can emit. And that's about it. The last thing we do is we're just going to create a little helper to show the stream in a video tag. So you give it the video tag, you give it the stream, and then it just does this simple creation of the URL, setting it as the source, and calling play. Really simple. So cool. That's how you get access to the user's camera. But after you have that, how do you actually find the peer you want to talk to? So in WebRTC, they leave this up to you. It's up to the user to figure out, it's up to the application writer to figure out how peers are going to discover each other. So what we're going to do is we're going to have a central server that just kind of coordinates which peers are online. And when one peer connects, it says, please introduce me to the next peer that connects. And then whoever connects next will get introduced, and those two people will be in a video chat. And if a third person comes during that time, what we're going to do is we're just going to have them wait until a fourth person comes. So we're only going to support two-way chat for this Omegle clone. And so let's see how that would work. So that process is called signaling. And it's important. So remember, we're doing peer-to-peer here. So peers are going to talk directly to each other. But first, the peers need to learn about each other. They need to learn what the other person's IP address is, what their port is. And so we need to do signaling. And so signaling involves a central server. And it kind of has a flow like this. So first we get UserMedia. And that has a callback that gives us the stream, the video stream. After we've done that, we create this, we initialize this constructor called RTC peer connection. And this is what's going to allow us to actually this tells the browser that we want to actually do a peer-to-peer connection. So it creates this object, and then we call addStream on that object, saying that and passing it the stream. So we say this is the video that we want to send to the other side. So once we do that, it's going to emit this event that says, oh, negotiation is needed. So it means that the ad stream didn't really do anything yet, and now it's our job to make sure that we send the necessary data to the other side so that they'll actually get the video. So we handle this event, by calling create offer. So that returns this thing called an offer. And you can think of it as just an opaque blob. It's actually, what it contains inside is the listing of all the codecs that your browser supports, all the video codecs. It includes an encryption key, a shared secret that's going to be used to encrypt your video. And it includes potentially a bunch of other things. And what you do is you call set local description, which says, OK, so here's the offer that I want to use. And the reason why that's necessary is it gives you the opportunity to change the offer if you want. So let's say you don't want to use a particular codec. You can delete that line from the blob, and then that codec won't be used. But in general, you don't need to do that. You just blindly call it, and you're good. So now we have a server, and we send the offer to the server, and the server sends the offer over to the peer we want to talk to. And that peer, when they receive the offer, they know, oh, someone wants to talk to me. And then they call the same constructor on their side, which creates the object. And then they call set remote description. So they have this offer, and they say, that's the offer from the other side. And then they can call getUserMedia, get their video stream, and do all that kind of setup. They call add stream. And then they say create answer. So this answer it's kind of like a challenge response thing. So the answer is based on the offer. So they get an answer and they send that. They set that as their local description, and then they send that to the other side. And then the other side sets that as their remote description. So it's parallel. Next, so now the peers know about each other. They know all the constraints. They're ready to connect. The only thing they don't know is what is the IP address of the other peer, and what is the port that I need to connect to. And so the way those are gathered is that the browser emits these events called ICE candidates. And so this event gets emitted, and the candidate object is literally just like a string that says, this is my IP and this is my port. And there can be multiple of these emitted if you have multiple interfaces on your machine, like Wi-Fi, Ethernet, a local IP, a public IP. And your job as the application developer is to just send those to the other side, just like you did with the offer and the answer. So you send the candidate over. The other side just says, oh, I got a candidate. OK, I'll add it. And then if any candidates get emitted on the other side, you just send that over to the other side, and then they add it as well. Really simple. And then finally, after all this, at some point, this add stream event will get emitted, and you'll have a stream which you can set as the source of video tag, and you'll see the video from the other side, which is awesome. And similarly, the same event will get emitted on the other side. So there's a lot of steps, but once you've done this, you have peer-to-peer video, which is really cool. Now, if you wanted to do a data channel, so you want to be able to send text data and binary data across, you would use this other method called create data channel, which returns a channel. And then the thing about data channels is they're inherently two-way. So do you remember in the video example, we called add stream on both sides? The reason why is because when you create a video stream, all you can do is send it to the other side, right? But with a data channel, they decided to make it two-way. So only one side needs to create a data channel, and then both of them can use that channel to talk to each other. So in this example, the left side is going to create the data channel. The right side is going to get an event that says, oh, the other guy created a channel. And now they both have a channel object, and they can use the channel object to send messages to each other. And they'll arrive on the other side as a message event. Cool. So I will show a little bit of how that would work. So we have this page here, this HTML page that we're going to use as our structure. It's really simple. And actually, before we go too much further, I want to show one more thing. So the thing is, this whole interface is kind of complicated. It's like there's too many steps, right? And like we don't want to deal with this every time we want to handle connections. So what we should do is create a class that kind of hides all that complexity away and just makes it easier. So I think it would be much nicer if we could do something like this, where we could just say new peer, and then you could say one side says that they're the initiator, and the other side would say they're not the initiator, and then you pass in the video stream in the constructor. And then here's what I'm imagining the flow would be like. So when you create a peer object, it will handle creating the data channel, adding the stream, all that stuff for you. And all it will do is emit this one event, signal, which says, I have some data, please send it to the other side. You don't even have to think about what the data is. We know it's an offer, but but the application doesn't need to know that. So whenever it gets a signal event, it just sends it across through the server to the other side. And all the other side has to know is, oh, I got some signaling data. I'm going to call the signal method with it. Okay? And then the other side does the same thing. It'll emit these signal events, and those will go across. And the other side, all it has to know is, oh, I got some signaling data, and then shove it into the peer object. So when candidates go through, it's the same thing. It's just a signal event. And same thing on the other side. They're just signal events. And then at some point, it will emit the stream to you, which is the video from the other side. And then it will say ready. And ready just means you can use the data channel now. So you can call send, and the message will show up on the other side. So I think this is a little bit simpler because your application only needs to handle the signal event and needs to call the signal method. You don't need to worry about all that other stuff. So we can write a class like that. Oops. OK. So that class is, where is it? Here we go. OK, cool. So I'm going to go through this kind of quickly. It's basically what you just saw in that diagram. Basically, what we're doing is we're doing these shims here to abstract away the browser differences. We're requiring some things. We're setting some config options on the pure connection object. This is just a stun server, and then we set up some handlers. So this event fires on the peer connection whenever the state of it changes. So once it goes into either the connected or completed state, that's just what they call it, we're going to emit a ready event. And whenever the connection state changes into the disconnected state, we're going to emit a close event. Then we're going to listen to the ICE candidate event, and that's the thing that just emits those candidates, those IP address and port pairs. And anytime one of those gets emitted, we just emit signal. We do some video setup and some data setup. And we create offer, set local description, and set up a data channel handler. Yeah, I mean, so it's exactly what I showed in the slides. We call create data channel up here. And then the event will get emitted down here. Anyway, I'll post the code online for this. It's a little bit more than I actually thought I would be able to show. So let's skip right into the last part. So right here we have this is actually the client-side code. So it's surprisingly simple because of this peer class that we just wrote. So all we're going to do is set up some variables for DOM nodes. And then we're going to have some little helper functions for disabling and enabling parts of the UI, like the send button and stuff. And we're going to have a little method for displaying chat messages on the screen whenever one comes in from the other side. And then we're going to create one of these. We're going to create a WebSocket, which is going to talk to the server, which is going to help us out to find peers. So once the socket's ready, we're going to get the user's media. And then we're going to show the video into a local video tag in the browser. Then we call next, which is the way we get new peers. So all we do to get a new peer is we send a message to the server with the type of peer. And then that tells the server we're looking to be introduced to another peer. So when another peer arrives, it will send us a peer message with all of the with their offer and their answer. And so this is what a peer message looks like. So this is the way we handle it. We create one of those peer objects. We say whether we're the initiator or not. And then the peer. So now this is basically the abstraction that we created over the peer connection. So it's going to emit these different events. So when the peer tells us they're ready, we say that by just showing a little message. When the peer sends us signaling data, when the peer emits signaling data, we just send that to the other side. When the peer emits a stream, we just show the stream. When the peer sends us a chat, we just show the chat, and that's basically it. And the last thing we need to do is just, when we receive signaling data, we just need to pass it into the peer object. And the very last thing is we just have a send method to send chats to the other side using the send method on the peer object. Really simple. So tying all that together, what we end up with is this demo right here. which will either be really awesome or will be a horrible fail depending on if the network cooperates. So everyone go to webtorrent.io:8080. And this is what we just built. So I'm going to be matched with a random, oh my god, there's a lot of you. I've not tested it with this many people. OK, cool. Yay, it worked. So I got a random person. Who is that? Raise your hand. Hey. All right, so we can talk to each other. Wow, that's 45. That's insane. Cool, so we're talking to each other. Nice. Now I'm going to click the next button, and I should be paired with someone else. Same guy, OK. Hey, what's going on? Let's try a different person. So everyone right now is getting paired with different people. And, huh? What? Oh, really? OK. Well, it's not as random as I'd like, but anyway. So that's the demo. Cool. So anyway, if you want to check out the code for this, the complete code is online at GitHub at this URL. And if you want to check out the Peer class that we wrote together, that's online at this URL. It's its own NPM module. And go forth and hack. Build great things with WebRTC, please. And check out WebTorrent if you're interested in that project. Please share your feedback and give it a shot. And wish you guys all luck. Happy hacking. Thanks.